Okay, welcome to Chapter 3, Light and Exposure. This is kind of a long one, so you might want to get out your notes and pause it. I am following the book pretty closely, chapter by chapter, line by line, so this is a pretty important chapter to understand and get a hold of. You might get confused, you might want to read this a few times, and review this PowerPoint a couple of times too. Light. Light's a key ingredient in photography. We can only see a small visible spectrum, but this visible spectrum has seemingly endless colors, tones, shades, and values. And this is what we, as photographers, are constantly trying to capture and want to get as rich and real as possible. There are many ways to control the light that touches your sensor. There are simple ways, but they're not very accurate, and then there are more complex ways that are more accurate, and I'm going to cover a few. But again, like I said earlier, my main goal is I want you to control your camera, and I don't want the camera controlling you. More often I see people where they don't get the shot they want because they don't understand how their camera works. I don't want that to happen to you. Exposing your sensor, in this case, I used to say film, can happen in many ways. The main goal is to control your exposure and get the correct exposure. If you look at your text on page 7, there's the middle column, and this is one of the oldest and simplest exposure guides. It says on a bright sunny day you can shoot at 250 and use f/16 if you're someplace around sand or snow. If you are like on the grass near the trees, you can use f/11. But what if you don't want the fast shutter speed of 250 or 125? Then you're out of luck. What do you do? How do you change that? And that's something that people don't always understand. So the other example is it says, 125 and f8 for weak sun. What exactly is weak sun? Cloudy bright, you can use 125 shutter speed and f5.6, or an open shade, you can use 125 and 5.4. But how often are we in open shade? Does this system work? Yes, but it leaves a lot of questions and unanswered things for photographers and wondering what do you do indoors on rainy days, or if you don't want your picture to look the way that shutter speed or aperture will make your picture, or I should say photograph, look. At this point you might be thinking the auto setting would be easier to use on your camera, and you're right, it is. And that's what most people do, is they set it to auto and they never take it off. And that's not a bad thing to do, to use auto, but you should get out of the habit of using it. There are times when auto is great. Do I use it? Yeah. Taking snapshots, family vacations, anytime I need a quick, fast image, I don't have time to think about it. I don't want to think about it. I don't really care about the aperture f-stop. I just want my subject to be taken care of, and it doesn't matter to me what the background is like. And so a good example is the image up top here of my son at the St. Louis Zoo holding some squid. Wanted to get a quick picture. Ideally, do I want the depth of field to be like that where I see everyone else in the audience? No, but I didn't have the time or the right angle or permission to get closer to the big fish pond, I guess you would call it. So I just leaned over, snapped what I got, and that worked out just fine for that purpose. What's my preferred method for choosing a correct exposure? As long as I don't have a difficult lighting situation like bright light coming into the camera, or I'm at the beach or some snow where a lot of light is reflecting back up, I prefer to use the AV or TV settings. Yours might say S or A, or you might just have the shutter setting or the aperture setting, and this is basically how it works. I set the camera to A or AV depending on your camera, and I pick the aperture I want to use. I'm going to say it's 22 today. And then the camera picks the correct or best shutter speed for the amount of light that's hitting my subject at that time. Why did I pick 22? Because I wanted a long depth of field. I didn't care about my shutter speed. But I'd also check to see what my shutter speed is to make sure the subject I'm taking won't be blurry, or I don't need to use a tripod because my shutter speed is so slow, like at 1/8 of a second, where the camera needs to be set down or on a tripod. I can do the same process in TV mode, where I pick my shutter speed and I let the camera pick the aperture. Say I'm shooting an action shot, I know I need 500, I'll let the camera pick the aperture and I won't worry about it, and I just, and I might see that it's an aperture of 2 and realize I'm going to have a very shallow depth of field. Manual exposing mode, it can be a lot like TV or the AV mode. You're using the camera's built-in light meter to read the lighting on your subject, and in the manual mode the camera is going to tell you what combination will work with your aperture and your shutter speed, and then you set the camera to those. And then the nice thing about that is if you decide, hey, I don't like that shutter speed, I want to go faster, most cameras nowadays will, as you turn your shutter speed faster, adjust your aperture in the correct direction for what you need it to be. Or if you decide, hey, 5.6 doesn't give me the depth of field I need, you can change that, and then the camera will also change your shutter speed. So then the only time you need to remeter is if lighting on your subject changes. And this could be something as simple as a cloud going between the subject and the sun. If you're shooting indoors, it's probably not going to change too much. Sensors, pixels, resolution, all big things in digital photography. They all mean lots of different things to people. Here are some of the key things to remember. Your sensors, what records the light. The bigger the sensor, the better the quality. Most point and shoots have the same size sensor. It's now starting to change with DSLRs. They're starting to have lots of different sensor sizes out there. More pixels per inch, the better the quality. And that's basically the difference between a 6 megapixel, 8 megapixel, 10 megapixel, 12 megapixel, 20 megapixel camera. You're getting more pixels per inch. The better the quality, the bigger you can print. Okay? That's the other key factor. Even though the book says you can upsample an image, meaning after you take it, give it a higher resolution, it's highly discouraged. You're going to lose a lot of detail if you're shooting some fine detailed objects. The computer is going to make up what goes there, and it's not going to look very good. If you're not going to print any bigger than 11 by 14, that 4 or 6 megapixel camera you have will probably be good enough for most of people out there today. But 4 and 6 megapixel cameras are becoming obsolete. They're just not out there. More people want more megapixel, even though you don't really need them. The nice thing about the more megapixel is it does allow people to shoot in lower light settings. So my best advice is always set your camera to the highest resolution possible. If you've not done that yet, do it, because you can always reduce the resolution with Photoshop or Photoshop Elements or some other editing software. You can't effectively and as nicely increase or upsample the resolution. Color is a huge thing with digital photography. There are two basic types of color, additive color and subtractive color. Additive color mixes red, green, blue light, RGB, to match any color there is. And that's used in TV monitors, TVs, projectors, any type of light in theater where they mix light to make certain colors. Equal quantities of all three lights will give you gray. If you do really bright, you get white. And photographers usually work in this mode in programs like Photoshop. We tend to understand when we mix red and when we mix the different colors, what happens. Subtractive color is a little bit different, a little more complicated, and photographers don't usually use it, but you need to know about it, and that's called CMYK. C stands for cyan, which is a blue, M stands for magenta, Y is yellow, and K stands for black. And each color absorbs or subtracts one of the additive primaries. So an example, you can put cyan or blue on the paper and it removes red from the white light that we see and allows us to see a green, blue reflecting back. Photographers use CMYK to print photographs. You might not realize it. Most computer programs automatically switch the RGB to CMYK for printing purposes.